Okay, just let's start. Okay, I'm today to talk about evidence for effective applications of green and blue spaces on temperature-related cardiovascular mortality risks in Zhejiang province, China. Okay, extreme temperatures, there are serious danger to our public health. We'll talk about conditions like heat waves and cold spells, and both of which they may lead to increased health risks in worldwide. And here's the thing, according to the scientific forecast, the extreme temperature events may become even more severe in the future. They are going to be more frequent, longer lasting, and more intense. This trend is likely to lead to an escalation in health risks associated with extreme temperatures. And there is plenty of evidence showing that both extremely high and low temperatures will contribute to a significant increase in mortality rates. Indeed, among the numerous health risks we face, cardiovascular disease stand out as the leading cause of death worldwide. Cardiovascular death related to non-optimum temperatures is on the rise. While climate change is happening, people getting older and more extreme weather events occurring, the situation is likely going to get worse. In light of this, it is imperative to implement adaptive strategies and public health interventions aimed at reducing the negative effects of extreme temperatures. And we all know that green and blue spaces are treated as efficient, cost-effective, nature-based solutions that can significantly enhance thermal comfort. In recent years, there have been reports showing that the projective effect of green and blue spaces in reducing the risk of temperature-related mortality. And we can see that I listed them in the PowerPoint. Green spaces can modulate microclimate through shadowing, evapotranspiration, and photosynthesis. Meanwhile, blue spaces can create cool islands through the exchange of air convection due to its greater heat capacity than other materials on the land surface. However, we know that the capacity of green and blue spaces to regulate temperature is influenced by its size, shape, promotion of physical activity and social interactions, and they will be affected by vegetation structure and compositions. And we all know one thing that these features will be largely affected by the types of green and blue spaces. So, while green and blue spaces have been acknowledged as crucial nature-based solutions to combat thermal discomfort, the management of green-blue spaces still lacks evidence-based guidelines for planning and designing. So, in our study, we want to investigate how different types of green and blue spaces could affect the relationship between non-optimum temperatures and death in different levels of heat and cold. We explore the association from 2009 to 2020 in 1,085 subdistricts in Zhejiang province, China. We used the fine-scale population density data and developed new exposure indices that can reflect the access of subdistrict level residents to both overall and type-specific green-blue space. We evaluated how green and blue spaces might affect the situation by comparing temperature-related mortality risks in sub-districts with low and high levels of green and blue spaces. And here are some detailed information. Okay, first for the daily average temperature and humidity, we calculated it taking into account the number of people living there. To do this, we started by calculating hourly temperature and humidity. using observational data from over 4,000 automatic weather stations and the latest global atmospheric analysis dataset and a digital elevation model. To figure out the population density, we used the random forest models using data including POI, road network, digital elevation model, and data from various remote sensing sources. Finally, using all this information, we calculated the population weighted average of daily 24-hour mean temperature and humidity. And in order to access sub-district level resident exposure to green and blue spaces, we developed an exposure index for each type of green-blue space. We classified green space into 7 categories, and to the exposure index for the first six, from overall to a park, we used the or calculated the index as the ratio of the number of residents living within a buffer zone around a specific type of green space to the total population of a certain subdistrict. Buffer zones was established using the space boundaries according to maximum attraction distance, which can vary depending on the size of green spaces. We got boundaries from forest floor AOI data, and for the other uh, types, we used the OpenStreetMap. In addition to this, we also calculated the exposure index for overall green space. For this, we used the patches we mentioned above. And when it comes to street greenery, we used something called Green View Index as a way to measure people's green exposure. We placed sampling points along the road network and download street view images. And we calculated the average proportion of trees and plants in 5 images, matched each sampling point. After that, we took the average GVI of all sampling points within sub-districts to get the exposure index for street greenery in a certain area.
Please.
And we also classified the blue space to 5 types. And the calculation is similar to a green-blue space index. So I just skip it. And here's some results. This is the descriptive of analysis results, and we can see in the 12-year study period, we have observed an average of 75,183 CBD deaths per year. And this is the values of green space and blue cities exposure indices, just is on the right. And let's talk about the heat-related CBD mortality risks first. And we can see just from the picture, we found that when it comes to green spaces, the sub-districts with high levels of exposure to overall green spaces, forests, parks, nature reserves, and street greenery exhibit significantly lower risks. However, we didn't see these changes in relative risks when it comes to subdistricts with lots of grass, farms, or scrubs. And for blue spaces, just the blue ones, we saw that a protective effect of heat-related CBD mortality only for overall blue spaces and lakes. And we didn't see the protective effects for rivers, reservoirs, wetlands, or coastal areas. And when it comes to coast-related CBD mortalities, the situation is very different. During the extremely cold days, we found that subdistricts with higher levels of exposure to rivers and coasts had significantly lower mortality risks. And this protective effect wasn't seen with other types of blue spaces, like overall blue spaces, lakes, grasslands, and reservoirs. And similarly, we didn't see green space show protective effects. Okay, there comes the conclusion. We've found is that both green and blue spaces can help protect against health risks when temperatures are high. Specifically, we saw that higher exposures to forests, parks, nature reserves, and street greenery, along with lakes, are associated with decreased heat-related civilian mortalities. However, when it's cold, only certain types of blue spaces, specifically rivers and coasts, offer this protective effect. Interestingly, blue space seem to have a larger benefit than green space. And based on what we found, we have a couple of suggestions for urban planning and public health policy. On one hand, reducing inequalities in the spatial distribution of green and blue space. This means that when we are planning our cities, we should aim to ensure that everyone has equal access to these spaces, regardless of where they live. This could help risk health disparities. And on the other hand, we should protect and enhance our green and blue spaces. This could mean conserving forests and nature reserves, optimizing the spatial layout of parks, planting more trees along streets, maximizing the use of river and lake resources when constructing blue spaces, and improving access to coast. Okay, thank you for listening.
So any question?